Record start.
Sarvebhya Namo Namah. This is the course on Sanatana Dharma for youth. We are having the third lecture in the series of Vedic mathematics. Dr. Goutham Mukherjee will take the class today. We will start with Prarthana from Aditi.
Shuklam Bharataram Vishnum Shashivarnam Chaturbhujam Prasannavadhanam Dhyaye Sarva Vignopashantaye Saraswati Namastubhyam Varade Kamarupini Vidyarambham Karishyami Siddhir Bhavati Me Sada. Hari Om Shri Gurubhyo Namaha.
Over to you, Gautamji. Dr. Goutham Mukherjee will continue the class. We have done yesterday, we had done multiplications and divisions in Vedic math. Dr. Goutham Mukherjee, over to you.
Thank you, Shogandiji. Namaskar. Sarika Namaskar. Now that yesterday just we started, I repeat that part. So far, we have seen that we whatever our goal of division was to when we divide a dividend by a divisor, we ended up in getting a quotient and remainder. However, so therefore the relation between these four quantities are E is equal to E, if E is the dividend, E is equal to D into Q plus R, where D and Q are the dividend, quotient, and remainder respectively. Or you can see by dividing everything, both the sides by D, E by D is equal to Q plus R by D. And R is less than D here. That was the condition of the division, and it is the definition of a remainder. Now, depending upon the requirements, we can go further, not stopping at remainder. We can go to the fraction and we express in that format. The 15 divided by 4 is equal to 3 whole and remainder 3 and quotient 3. So 15 by 4 is equal to 3 whole and 3 by 4 or 3.75. So these are the called different notation, or the fractional notation, or in the notation of decimal points. For an expression E by D, where E greater than D, we can always express as a whole part, part plus a fraction of the form N by D. Now the N by D, so calling them remainder and divisor, we call them numerator and denominator. In the general fraction, we call them numerator and denominator. So is it clear? It is all the regular mathematics. Now, any rational fraction of the form N by D. Now we are going to the characteristics what kind of we get in the fractions. N by D becomes a terminating decimal when the denominator is purely comprising of powers of 2 and 5. Because it is decimal system, and decimal system in the 10 has two factors, namely 2 and 5. So therefore, we get like this: half is equal to 0.5 and 1/4 to 0.25 and so on. Here, the number of places in that terminating decimal will be the maximum power between the number of power of 2 or power of 5. Like 1/4, this has 2 to the power 2, so it has 2 decimal power 0.25. Similarly, suppose 1 by 50, it has 2 to the power 5 to the power 2 into 2. So maximum power is 2. It is coming from 5, so it is 0.02. So likewise, 1 by 25. So there are 2 powers of 5, so you get 2 decimal points, 2 digits after decimal point. 0.04 that way. 100 also is whether it is 100 or 50 and 2.5. These are all having maximum power is 2. So therefore, it is coming 2 decimal point. But after decimal point, 2 digits. A rational fraction whose denominator ends in 1, 3, 7 or 9 becomes a recurring decimal. 1 by 3 is 0.3 dot. This means actually we put a dot here. 1 by 7 is 0.142857 within 2 dots here and here. Six digits recurring. 1 by 11 is 0.0909, etc. Decimal, 2 digits recurring. 8 by 13 is equal to 0.615384. These also 6 points will be recurring. So this is about, we came to two categories where it is purely of 2 and 5 factors, or this purely 1, 3, 7, and 9. Any other category will be having a fixed part as well as a recurring. So there is some calculations shown here. Length of the non-recurring part will be the greater one between maximum power of 2 and maximum power of 5 present in the denominator. Like in the terminating decimal, we have number of digits terminating there. Here it is that fixed digit will be maximum power of 2. See, 48 actually 2 to the power 4. So there were 4 digits fixed. After that, there is 6 repeating here. So that way it is the expression, and actually there is a little algebra calculation. So one can see it, what is the reason of having a fixed part and a decimal part. You just go there. This is not our main topic today, so you can just know about the characteristics of that. If you can come back. And there is a way to decimal form to rational form transformation. It is like this. So you do as many as point terminating decimal. There is no repetition. So it is 10 to the power so many things, so many numbers you put, and you just to cancel that, it will come out. 5.48. This is 548 divided by 100. So it is like this. For pure recurring decimal, put as many nines in the denominator. For example, 0.3333, 3 by 9 is 1 by 3. 0.4545, etc. 45 divided by as many nines as recurring. So there are 4, 5 repeating, 2 digits repeating, we write 2 numbers of 99, so 5 by 11. 142857 repeating 142857, we put 6 numbers of 9, and when you cancel it, it becomes 1 by 7. And for mixed kind of decimal, how do you do? 0.1 and 6 repeating, you have to do total minus the part which is fixed. So 16 minus 1, and put as many nines as the number of repeating ones, digits, and as many zeros as the number of non-repeating parts. So it becomes like this, 1 by 6. 6, 8, 6, 81, 81, 81. So 681 minus the 6, the fixed part, divided by the 81, 81, 2 digits are between 2 numbers of 9, and 1 was only 6 part 1 fixed, so 1 number of 0. So this becomes, upon cancellation, becomes like this. So here it is also like this. It is shown. You can see that how it is coming. Now, after opting the remainder in the Nikhila method, we can put decimal, keep on putting decimal point. As you in conventional also, we keep on doing like that. But in that process, both the Nikhila and conventional method, they have become very long and cumbersome. I have shown some. You can in a later time you can just go through them. This is not my main point of discussion today, so I just skip. Actually, conventional division also you get these numbers 1 by 7, something by 7, 142857. Here also in Nikhila method also you get, it is possible to get by applying zeros and so on. So we have shown something calculation. Now I come to it later. It is an Excel screenshot. Now, regarding decimal, now I go to only that case where it's pure recurring. I mean, what I told, how did you remember? What are the denominator ending in what digits will give you that pure recurring? What are the things that is will come? What are the digits? 1, 3, 7, and 9. Because 5 will be 5 will be either it is pure 5 or it will be a composite having 5 as a factor. So it will have, if it is composite with 5 as a factor, it will be having a fixed part as well as a recurring part. If it is purely 5, 25, 125, etc., then it will be pure terminating. Okay. Now, so first I will show the case where the denominator ends in 9, not 1, 3, 7, but only 9. For 1, 3, and 7, what you have to do, that will be, we'll discuss later. For 1, 9, we'll be showing the ways of, say, 1 by 19, 1 by something by, or 1 by or something by 19, something by 29, something by 49. These will be quite long, you will find. It will be not many steps. There are 18 digits actually. 18 digits, so it will be very long. So what here we'll do, we'll apply the natural method and one line method, and it's called Ekadikano Purven. And we'll reveal that cyclic property will be adding. The basic online method is directly applicable for denominators ending in 9. Others, you have to do something, I'll show you. What is the procedure? So when you do division by 19, instead of dividing by 19, you divide by 2. Later on, we'll explain why it is divided by 2. So it is like this. You find first a digit divisor, which is the denominator, which is ending in 9, plus 1 divided by 10. Or Purveno is 1, 1 plus 1, 2. So here the digit divisor becomes 2 in case of 19. Now you start like this, put a decimal point. Now this division will be a special way, not ordinary division, but in a special way. Aditi, if I divide 1 by 2, what will be my quotient and remainder?
You'll get 0.5. You won't have any remainder.
No, I didn't get you. Some sound problem was there. If I divide, say 1, I'm dividing by 2. What will be my quotient and remainder?
You would get 0.5, right? Remainder, you wouldn't get anything, right?
No, here the concept must be clear. How you got this 0.5? You remember how you got? That we forget this part and skip, and then directly go to many persons we have seen, many expert persons also, they also say the same answer, 0.5. No, it is not. But I've seen also some more mathematician persons who are they'll do it very immediately, they told, because the concept is, if I divide 1 by 2, or in general, if the dividend, I mean the numerator is obviously less than denominator here. So the dividend is less than the divisor. Dividend is less than divisor. So no, here in this particular case, 1 by 2, I'm telling 1. You are dividing by 2. Okay. So in this case, in general, if the dividend is less than divisor, what will be the quotient? You remember the division? We put like these 2 circles and put. If we find that it is not coming, what do we put there in the quotient?
0. I was on mute. Sorry.
You must still
Yeah.
have. That is, it should be first we put 0. After that, with the remainder, we put a decimal point, and with the right of the remainder, put 0. After putting a decimal point, then we see again continue like that, isn't it? That so initially, so if you tell me now, if we divide 1 by 2, what will be my quotient? Quotient will be how much, and remainder will be how much?
0 and your remainder would be 1.
Well, obviously, this is the thing. That's what I want to answer. Because some people, they directly go to 0.5. But 0.5 came out. It came because we put a dot and then you put a 0 and then after next line, so this 10 is matched by 2 into 5. So therefore 0.5 came. Okay, isn't it? So now this is the lowest.
Yeah.
Main
Yeah.
reason. Only will be considering quotient and remainder. So now, so 1 divided by 2, we get quotient as 0 and remainder 1. In the result line, we put Q, we write like this. We write 0 we write, and 1 below a little left, a little smaller maybe. So divide Q 0 with this R, we get 10 digits and next division. What class? In the real life, we put, so it becomes like this. We put 10 digits. Now, in the next division, we use this remainder as it my 10th digit. So it becomes as if 10. And dividing this 2 by dividing by 2, it gives 5. We get 5 and remainder 0. The result becomes 0.05. Divide 5 by 2. So it becomes, quotient becomes 2 and remainder 1, which makes the next division as 12. The result is 0.052. That way it goes. The next year I'll detail, I'll just tell me. Better you write. Actually, this writing is not there. Just I'll explain from here. The successive quotient and remainder, these are, we write in this format. Q, we write quotient and remainder in slightly left in smaller percent. Okay. From beginning of 1 by 19, we do remainders are like this. See? So it is actually, I am finding 1 by 19, isn't it? So 1, as you write 1 divided by 2. You also write on the paper, you write 1 divided by 2. Okay. So 0 point, and then that 1 divided by 2, my quotient is 0 and remainder 1. Okay. This looks like 10. You just see, looks like 10, isn't it? Yes. Now 10 divided by 2, we keep on dividing with 2 always by 2 only. So 10 divided by 2 is 5 with no remainder. So remainder, either you can skip this or put a 0. Or you can need not write 0. I'm here to in this format to avoid any confusion. I wrote 0, but actually you need not write 0. Now this is 0, 5. 5 divided by 2. What is the quotient and remainder? 2 quotient and 1 remainder. Okay. This looks like 12. Now it looks like 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 again, when we divide by 2, it becomes 1 quotient and 1 remainder. It looks like 11. Huh? Correct? Then 11 divided by 2, 5 quotient and 1 remainder. Correct?
Yes. Yes.
15 divided by 2, 7 quotient, 1
7
remainder.
question. Yeah.
17 divided by 2, 8 quotient, 1 remainder.
Yeah.
18 divided by 2, 9.
9, 0. Yeah.
9 divided by 2, 4 quotient, 1 remainder.
4. Yeah.
And 14 divided by 2 is 7. 7 divided by 2 is 3 quotient,
3.
1 remainder.
Yeah.
6 quotient, then 3 quotient, 1 remainder, 13. 6 quotient,
13.
1
So
remainder.
yeah, 6 question, 1 remainder. Yeah.
16. 16 divided by 2, 8. 8 divided by 2,
question, 0.
4.
4.
4 divided
Yeah.
by 2 is 2. 2
2.
divided by 2 is 1. We come
1.
to 1.
0
I started with 1 divided by 2. So again, obviously, we'll get this. So therefore, we put a dot
Yeah.
here and a dot here. And this length is 19 minus 1, which is 18. Here is full cycle. Full cycle will be having a number of repeating digits as denominator minus 1. Here denominator is 19. So this 19 minus 1 is 18, and there will be 18 digits repeating in case of 19.
Yeah. Okay. Yeah. Yeah.
Now, I could have gotten this thing from right to left also. So here I 1 by 19, so we should have started with 1. 1 into 2. 2 into 2, 4. 4 into 2 is 8. 8 into 2 is 16. 6 to the right and 1 as a carry here.
Yeah.
Now, 6 into 2, we do 3.
12. 12 plus 1, 13.
12 plus 1.
Yeah.
Whatever was remainder from this left to right, it will be carried from right to left. So that carry has to be added. 6 into 2 plus 1 is 13.
13,
then
yeah.
Put 1 as a carry. 3 into 2 plus 1 is 7. That way, you can complete and go to 0. And then again, 0 into 2 plus 1 is 1. So you understand that, it will repeat.
Yeah.
That way also could have been done.
Yeah.
There is another third way also.
Okay.
You divide the whole 18 digits into half, you'll find that. Half is here. Half is at 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. It ends at 8.
Okay.
Then find this 9 minus 0 is 9, 9 minus 5 is 4, 9 minus 2 is 7.
Yeah.
If you write like, if you fold it like this, below, what will happen? You'll keep it.
Yeah.
You find that their addition is, you could have gotten, the rest of the thing could have gotten by dividing from, by subtracting from 9, and remainder subtracting from 1, because it is, the digit divisor was 2. So 2 minus 1 is 1. So 1 will be that.
Yeah.
We can do. Whatever is there also 1. So 1 and 1. So 8 will be, we will have 0. 6. 6 with 0. So 9 minus 6 is 3. That 3 is corresponding place. 3 is coming with remainder 1. So therefore, this we follow like that. Sequence. Now, the important thing is like this, that I discussed in this, I discussed here, because here everything is completely written here. Now, now we are actually, how many total fractions possible with denominator 19? How many fractions possible?
Till 9, like 1 to 9.
No. 4. 1 by 19, 2
1
by
to
19.
18. Yeah, 1 to 18.
There will be total 18, 19. Suppose somebody asks you, to find, right, suppose gives you a task that you find all the decimal, all the 18 digits, or all the fractions 1 by 18 to 1 by 19 to 18 by 19. So how much? Imagine how much effort you have to make. 1 by 19 itself will be very. Again, 2 by 19. Probably one copybook will full with 1 by 19 to 18 by 19. But here, see, this particular one line gives you the answer of all the fractions. You tell me what do you want? How much by 19 you want?
16 by 19.
16 by 19. You find where is 16 here. So 16 means 6 will be
4 0
and 1 as the This is 16.
Oh, okay. Yeah.
So had we gotten 16 by 19, we would have first gotten 16 would be divided by 2. Because here this digit divisor in case of 19 is 2. 16 divided by 2 is 8. So we start with 8. So 16 divided by 19 will be 0.8421. Then again, because it was continuing, no? 8.8421, 05263, 1, 5789, 7, 3, 6. Are you seeing my arrow? Can you see my? I was putting the arrow.
Yeah.
Or I started into laser pointer. Is it okay, no? The arrow can be seen. Huh?
Yeah. We can. Yeah.
Now, one more you see, tell me. Now you yourself, suppose you want say 5 by I
5
want
by 90.
5 by 9. What will we start?
From the second digit, like 50. Right. So
You start with what?
yeah. 216030.
You don't have to write this, but when you give it right, you don't have to write the remainders. Suppose somebody asks you 5 by 19. 5 by 19 will be 0.2631 like this. You tell me 0.26315 and goes like this, and then it ends up at 5.
5. Yeah.
This remainder information is required for making this transparent, but when you write, somebody asks you final answer, with that obviously. Okay.
Yeah.
Sir, I have a doubt. Now, suppose if we have 21 by 19, how will we be doing it?
No, 21 by 19 cannot be, because it is 1 full and 2 by 19.
Okay.
And here it is only for numerator less than denominator. You are doing this fraction, no? If it is more, then obviously it will be some full part,
Yes,
and then
full part. Yes.
I am concerned about the whatever is coming after this decimal point.
Understood.
Instead of 0 point, it will be 1 point. 1 point, and then it will 2 by 21 by 2 by 19. So it will be 1.1052631 and so on.
Okay.
One will okay. Now this is about this 19. These are all this time here. What I told by seeing this, whatever I told on voice, it is all written here. Now I come to 29. So 29, what is my digit divisor? Again, 1 more than the previous. So whether you can write, it will be 3.
30. Yeah, 3.
Previous of 29 is 2. And 2 plus 1 is 3. 1 more than the previous, the 2 plus 3. But digit divisor is 3. So I repeat this way. In a similar format, I do like this. 1 divided by 3. How much quotient and how much remainder?
0 and
So
1
is quotient, as I told, always if the remainder is smaller, if the 1 by 3, so 1 is less than 3, so always it will be quotient will be 0. So 0 and 1 will be remainder. And then 10. 10 when divided by 3, it becomes 3 quotient and 1 remainder. So 13 again divided by 3, 4 quotient, 1 remainder. 4 quotient, that way it goes. And it will go, actually this is 29 minus 2, it will be, length will be 28 digits.
Okay,
28.
Yeah.
Okay. So what I did here, I purposefully, I folded it here. You just put in the next line.
Yeah.
You will find that after doing this thing, going like that, similarly, 24 divided by 3 is 8, without even 8, again 2, again 1, 7, and so on, goes on like that.
Yeah.
And after 14 digit, what I did, I could have, instead of continuing, I could have just subtract them from 9. 9 minus 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 4 is 5, 9 minus 8 is 1. And remainder is, this digit divisor is 3, and 3 minus 1 is 2. The total will be 2. If it is 1, then you will put 1. If it is put 1, 1, 1, 1. If it is 2, 2 minus 2 is 0.
0. Yeah.
If it is 0, 2 minus 0 is 2. So wherever 0 is 2, there will be 2 is 0. 1 will be 1. That way goes, all the information is here.
Yeah.
Then all the fractions from 1 by 29 to 28 by 29, all the fractions are here transparent. You tell me any fraction, you tell me what do I want, what by 29 you want?
5.
5 by 29. You tell me where is that?
It's like second line.
Second
Fourth
line?
one. Fourth one.
Second line, the fourth one. Yes, because this 5 is coming from 25. This 5 is from 15.
15. Yeah.
I want 5 by 29, so it will be after 5. This point 1, 2, 4, 1, 3, and goes like that. It ends up in 5.
5. Yeah.
Or also I can do right to left in case of 1 by 99. Show you 1 into 3. 3 into 3 is 9. 9 into 3 is 27. And 7 you write, 2 right here. 7 into 3 is 21. Plus this 2 is 23. That like that.
Yeah.
Or that I fold already have shown. So it looks like it had 28 digits, a full cycle. Full cycle, you get all the answers in one line, like that. All the activity. Now we come to, so here these are whatever I have discussed, this is all written here so that you do not forget. There's some guess is there, exercise are there, the exercise also you can do.
Yeah.
Now, there is a way, do you know Excel, Microsoft Excel? Did you learn it?
Yeah. No.
Huh?
Yeah. Like anything other than the number by itself.
Later on we can discuss sometime. But here you see, this is a little bit big one. So I did some Excel spreadsheet one by anything n by a9. So far I have done. And in case of 59 digit divisor is 6. Okay.
Yeah.
So here it came like this. The 1 by 6 is 0 and 1, 10. 10 divided by 6, 1 percent, 4 remainder, 41. 41 divided by 6, it is 6%. It goes and it has 58 digits. Also that same way.
Yeah.
So what is the explanation? I come to explanation now. Binary binomial expansion did you learn?
I don't really remember. So.
You learned it. Binomial expansion, if you see 1 plus x square, 1 plus 1 plus x square. So you have 1 plus twice x plus x. 1 plus x, 1 plus 3x plus 3x square plus x cube. Like, but if x is less than 1 and it is minus 1, or minus 1, it becomes in this form. 1 plus x square plus x cube plus x4 and x to the power 4 and so on. And if we take common, 1 plus x taken common, 1 plus x taken common, 1 plus x taken common, it goes on infinitely. If x is less than 1. So this 1 by 19, 1 by 29, these all can be expressed as 1 by 10 n minus 1. In case of 19, it is 2. Twice in case of 29, it is 3. 3 into 10 minus 1. 4 into that way. So this can be expressed in this way. So if you have that this format, 1 minus x to the power minus 1. More clearly, I have shown in this slide. 1 by 10 minus 1, imagine it is 1 by 19. So it will be like 1 by 20 into 1 by 1 minus 20. Okay. Imagine it is 2. So then 1 by 20 is made out, and then 1 minus 1 by over minus 1. 1 by 20 is obviously less than 1. So it goes like that, 1 by 20, 1 plus 1 by 20, 1 plus 1 will be square, cube, and so on. So again, if I can express it also in that form, 1 by 20 is coming out. 1 plus 1 by 20. 1 plus 1 by 20, 1 plus 1 by 20. Or something by only one, not only one. Suppose we come by 5 by 19. So 5 by 19 will be 5 by 20, then 1 plus 1 by 20, 1 plus 1 by 20, 1 plus 1 by 20, and so on. So the procedure actually, if I go back to that procedure, 19. So 1 by 20 is 0.05. 1 by 20 is simply 0.05.
Yeah.
But this is about the first term. Actually, that is the most important. I divided by 2 here. Dividing by 2 are the procedure. But effectively, if we see, we are dividing actually by 20 as per the requirement of the binary express, because we are throwing the next decimal point. This is the next decimal position. 10 to the power 1, the power of 10 gets reduced. So we are basically dividing also by 10. So dividing by 2 as well as divided by 10, that means divided by 20. So that is 1 by 20 is 0.05, ends there. But there are more terms. And that it is get term by term, it is giving rise to, term by term, it is giving rise to this 2, 6, 3, 1. All these are coming basically from the these ones. This one, it is 1 by 20, 0.05, this one. But there is something, it's not, it doesn't end here. It 3, all the different terms are coming one by one like this. And the procedure is that. Is it not interesting? There is a relation between all the procedure, something very coming like that. It is coming originally is because of the binomial.
Yeah.
Okay. Now I come to other denominators. Like suppose, for example, we have seen only for, because the binomial expansion is applicable when it is like this, 1 by 19, 1 by 29, 1 by 39. What will happen? Something is, if it is 10 minus 3, it will be very complicated. You cannot, 1 by 17, you cannot directly come from here. It's very difficult. We cannot manage with that 3. You have to always, this procedure will be totally failing. We cannot be directly applicable. So what we do for that? That's next I discuss. I give an example of 1 by 7. 1 by 7. For denominators ending in 1, 3, or 7, we have to multiply both numerator and denominator by 9, 3, and 1, 9, 3, and 7 respectively. 9 into 1 is 9 again. 3 into 3 is 9. 7 into 7, 49 ends up in 9. Okay? Okay? So
yes, sir, you get like the denominator, I mean, the last digit as
denominator
9.
should be ending in 9, so that we can apply that procedure. To get the denominator ending in 9 and follow the same procedure. Thus, 1 by 17 is expressed as 7 by 49. We start with 7. We do not start with 1. 1 by 49 will be something else. I want 1 by 7. So it is 7 by 49. So we start with 7 and divide by 5, because 5 is ekadikanu purvena, 4 plus 1 is 5.
Yeah, 4 plus 1 is 5.
7 divided by 5. So
1 remainder 2,
1 quotient, 2 remainder. 21. 21 divided by
5. 4, 1 remainder.
4 quotient not. 14. 14 divided by 5.
Okay, 2, 4 remainder.
2 and 4 remainder. 42 divided by 5.
8, 2 remainder.
28 divided by
5. 5, 3 remainder.
35 divided by 5.
7, 0 remainder.
Remainder. We start with 7 and 0 remainder.
Yeah.
We put dot between 1 and 7. So 142857. It has only 6 digits because 7 minus 1 is 6.
Okay. Yeah.
But it is also full cycle. And then here also you'll find that we cut it half. 1 plus 8 is 9, 4 plus 5 is 9, and 2 plus 7 is 9. 3, 3. Good. Okay.
But why for the for 1 by, if it's 1 by 49, we take it as 49 minus 1, but for this we take it as 7 minus 1. Like for the full cycle.
If suppose you want 1 by 49, then we start with 1. So there will be 0 quotient on remainder 10. 10 divided by 5 is 2. So become next will be 2.
Yeah.
2. And
Okay,
without 2 divided, so it is 0 and 2, 20, then will be 4. That way it will go like that.
Okay.
Okay.
Whatever our numerator is.
Length will be 42. In case of anything other than this 1 by 7, something by 7 category, if we do something, say 37 by 49, all that will have length will be 42 degrees. 42. Plus 6 becomes 48. That 48 is actually 49 minus 1. That is very interesting. Saw that very peculiarly. That is separate question here. Now, you tell me whether you get that same logic applies from there. Whether you get in one line, 1 by 7, 2 by 7, 3 by 7, everything, up to 6 by 7, whether you get it, do you see it or not?
Yeah.
How?
Right.
Suppose
1 by 7 would be
0,
7. 1 by 7 would be 0, 7. 2 by 7 would be no, you can't.
No, yes, but you here see, you have to multiply by 7. So 2 by 7 is 2 by 7 is 0.2857.
14. Okay, yeah.
3 by 7 is 3 into 7 is 21. 21 is here. So 3 by 7 will be 0.428571. Okay. So say 6 by 7. 6 into 7 is 42. 42 is here. 42 it is 0.857142. That way, that is similarly here.
Yeah.
1 by 13. 1 by 13, we have to do by 3 by 39.
Yeah.
3 and divide by 4.
Divide by 4,
30.
3,
Again, 7 quotient, 2 remainder, 27, 6 quotient. That way, it also has 6 lengths. Here, there is a peculiarity. Here, we get 2 numbers of cycles with 6 length each. 6 length, it is not 12 length. It is not 1 cycle with 12 length, but 2 cycles of 6 length. Here we are getting this 03 means 1 by 13. This is 12, this is 4 by 13. This is 3 by 13, 36. This is 12 by 13. This is 27. Means it is how much? 9 by 30. This is 10 by 30. Other things, other getting another one. We can do, had we started, that you do. It is given to you by my task. Task you find 2 by 13. It is not coming here because 6 is not there. Only 06 is not there. So you do 2 by 13, okay? And what more are there in that cycle, you tell me. Now 1 by 17. 1 by 17 is 7 by 119. And 7 and divided by 12. 11 plus Ekadikanu Purveno. Purveno is 11. 11 plus 1 is 12. So you have to do, it has it's like I did it from Excel. See, like this.
Yeah.
7 by 1 is 7 divided by 12.
Yeah.
So it is 0 and 7. 70 divided by 12 is 5. 5 into 12 is 60 plus this 10, 70. So 105. Again, divided by 105 divided by 12, it becomes actually bigger. So you get more time and we get it finally.
Yeah.
But now, concept of single and multiple cycle. Here I put like this. Okay. That I already discussed it. Like this single and multiple. For 39, there are 6 cycle of length 6 each.
Okay.
For 39, we get like that. Okay.
Yeah.
And there will be 6 into 6, 6 length of 6 each, 6 into 6 is 36. But what about the other two? Other two are coming from here. 13 by 39 actually is 1 by 3. And 26 by 39 is 2 by 3. Therefore, those two total becomes 38. That way you can. For 49, there are 1 cycle with length 42 in, it's not mode, it's mode, and it is E is not there.
Okay.
7, not 0, and another length 7, where n mod 7 is equal to 0. But that is denominator is 1, 7. So like this was. Now I come to another thing. You understood what so far we have discussed,
Yeah.
what we have discussed?
Yeah.
Now I come to very interesting thing. This is normally, you do not get in the book this way, but this is just by hit and trial, you can say that this came out like that. How I'll tell you. For denominator ending in 1, for denominator ending in 7, we multiply by 7. Still it is manageable. Still it is manageable. But some denominator ending in 1, that is like 1 by 21, 1 by 31, 1 by 41. For 1 by 21, we have to multiply both the numerator and denominator by 9 to get ending in 9. So it becomes 1 by 21 becomes 9 by 189.
Yeah.
And digit divisor becomes 19. It is almost comparable by with 21. We wanted to avoid dividing by 21, but ended up dividing by 19. So this procedure actually fails. So it must be one line. This method needs a change. Then I consider like this: 1 by 21, 1 by 31, 1 by 41, etc. Their form is 1 by 10n plus 1. Either it was 10n minus 1, it is 10n minus 10n plus 1. Now, so therefore, in a similar fashion, we go to the binomial exponential of 1 plus x to the power minus 1. What is 1 plus x to the power minus 1? Earlier, 1 minus x to the power minus 1, everything was positive. Here it is alternating positive, negative, positive, negative. So 1 minus x plus x square plus x cube plus x square, like that, is equal to 1 minus x, 1 minus x, 1 minus x, goes out like that. Therefore, 1 by 10n plus 1 is, I got more clearly like this. Again, 1 by 21, you consider. 1 by 21 will be equal to 1 by 21, 1 by 1 plus 1 by 21. You go 1 by 21, 1 plus 1 by 21 to the power minus 1. So 1 by 21 bracket 1 minus 1 by 21 plus 1 by 21 square cube and so on. And then if we take again common, 1 by 21 bracket 1 by 1 minus 1 by 21, 1 minus 1 by 21, everything goes on like that. Similarly, something I say 5 by 21 is 5 by 21 into 1 minus 1 by 21, 1 minus 1 by 21, like that. Clear?
Yeah.
So procedure-wise, what do you do? Here actually, in a very fast go, I do not, you first try to first master that plan, master that thing. Here I've seen that I compared it in the Excel sheet calculation by the method of 9 by 159 and by 1 by 21 directly by the negative method. That method I had seen. That way. Here you have to see, but you listen very carefully the procedure. I am going to this 14 by 41 because there is no negative digits coming here.
Okay.
If the negative digits come, there is a way to handle it. But first we do without any negative digit, just the procedure. 14 by 41. We start dividing 14. Here digit divisor is same as this. Sorry, 14 by 41. Digit divisor is 4 itself. Not ekadikinu purbe now. This just the purbe now.
Okay.
It is not 10n minus 1, but it is 10n plus 1. So therefore, just that 4. So
Okay.
14 you have to start dividing by 4. In quotient is 3 and remainder is 2.
3, yeah, 3 and 2.
But if I had again 23 divided by 4, it will be going to our previous case, it will be actually 14.
25.
It will be 14 divided by 30, not 41.
Huh?
If we next one, if we do 23, if we work with 23, see 14 divided by 4 was 3 quotient and 2 remainder.
Yeah.
If I continue with 23, it will be like 14 by 39 it will go. In a positive method. It will be everything is positive. It was in case of what? In case of 39, isn't it?
Yeah.
1 by 10n plus 1. Here it was 1 by, sorry, it was 1 by 10n minus 1 it was. Here it is 1 by 10n plus 1. It will be negative.
Yeah.
How to do it negative? Instead of 20 plus 3, 23 is 23 plus 3, we wrote 20 minus 3. As if it vinculum is there, as if this 3 is minus. So 2 and it vinculum 3.
Okay.
So 20 minus 3, 17.
Yeah. Okay, yeah, 17. Okay.
17.
So
Now
you get
17 is divided by 4.
No.
4 quotient 1
Oh,
remains.
sorry, yeah. 4.
It is not 14.
Yeah.
While finally
Yeah.
we use this 3, 4, but now while doing the procedure, we imagine that it is negative 4. That means 10 minus 4 is 6.
10 minus 4, 6, yeah.
6 divided 4 is 1
1.
2 remainder. So instead of 20 plus 1, you will do 20 minus
1, 19.
19. So therefore, in procedure, I'm putting it in the bracket.
Yeah.
Bracket thing will not be using in final answer.
4 plus 16, 3. Yeah.
19 again. 4 quotient and 3
You'll get 4 remainder.
30 minus 4 is 30 minus 4 is
30 minus 4 is 26.
26. This 26 I'll divide by 4. 6 quotient, 2 remainder.
6
This 26,
remainder, 2.
26, 2, 20 minus 6.
14.
As if 6 is vinculum. So 6 is 14. Comes back to 14. So put a dot here and write on, you are writing on a pen and paper. So you put a dot on 3 and dot on 6. In calculator also, if you calculate, it will be 0.34146. 34146. You go like that.
Okay.
Now,
Yeah. Oh no.
Understand? Now, the another interesting part I didn't tell you is why you skip that. I'll tell you now. Simplest, you always keep 14 by 49, 14 by 41 I jumped into. But actually, first you think that, sir, why you didn't discuss 1 by 21, which is the first one is that after this procedure, the first one is 1 by 21. 1 by 21 is, it comes in the denominator of the form 1 by A1. So now 21, simply, it is 2 only. This calculation is not required, only this, remember that only the 2 has to be taken. Whatever is leaving the 1, you have to keep that. Now we proceed as follows. 1 divided by 2. 0 quotient 1 remainder. Earlier also got like that. Now we do it 10r minus q. That means 10r plus, instead of 10r plus q. So 10r minus 1 becomes 5. 5 and 0. You do not find any much difference. So again you do 0 and the 5 quotient 1, next one becomes 0.05. But 0, now it is quotient and quotient is 5 and remainder is 0.
Yeah.
Then it becomes 0 into 10 minus 5. So minus 5. my number to be divided by 2 now become -5. And what is -5 divided by 2? If we divide -5 by 2, what will be my quotient and what will be my remainder? 5 divided by 2 is quotient is 2 and remainder was 1. But -5 divided by 2, what is the quotient and what is remainder? You note that quotient cannot be negative, but quotient can be negative, but remainder cannot be negative. So my quotient is -3 and remainder 1. This has to be, because -3 into 2 plus 1 is -5.
Okay.
Then, so far the result is like this, 0.05 and then 3 over this quotient. Third quotient comes as -3. See, first quotient came like this, 0. It is usually 0 and 1. So first quotient was 0. Then become 10. 10 divided by 2 is 5. Second quotient became 5. Like earlier, you do not find much difference.
Yeah.
Then the third quotient, when it becomes, we have to be, instead of 5, we take -5. Because 0 and 5, 0 into 10 plus, instead of plus 5, 0 into 10 -5. So we got -5, and -5 divided by 2 is, quotient is -3 and remainder is 1. So it becomes 3 vinculum. Now again, and remainder is 1. So 10 into 1 minus this -3 means 13. It becomes 13 now. Instead of 7, it will become 13.
Yeah.
13 divided by 2 is, quotient is 6 and remainder 1. So now you write 0, 5, 3, 5, 3 and 6. Now this 0, 5, 3, 6. No, sorry, 0, 0, 5, 3 vinculum and 6. Then again, there was 6 quotient, 1 remainder. Now 10, this 10, instead of 10 minus 6 into 10 minus 10 plus 6 into 10 minus 6 is 4. So 4 divided by 2 is 2 quotient and 0 remainder. So 0, 5, 5, 3, 6, 2. Now again, it will again become negative. 10 into 10 will become negative. This negative divided by 2 is, quotient is -1 and remainder is 0. Result is 0.053 vinculum 6 to 1 vinculum. Now next dividend again, we find it, will end up in 1. So therefore, we started from 1. So therefore, 1 by 21 is 0.053 vinculum 6 to 1 vinculum. So if we clear the vinculum, it becomes like this. 0.0453 vinculum is 47, and after 6 is 6, and 1 vinculum is 19. So it is 0.047619. It has repeatability, repeating decimal 6. Clear?
Yeah.
And there will be 3 cycles of 6. 6 into 3 is 18, and there will be 2 more. 2 more will be, those will be 7 by 21 and 14 by 21, 1 by 3 and 2 by 3. So adding it to 20 by 21, total 20, and so in 21, the complete 20. Okay, 21 minus 1 is 20, and you have to somehow make up this 20. So how it is coming 20? There will be 3 cycles of this 6 length each, and 2 will be there for single cycles, 1 by 3 and 1 by 3 and 2 by 3. 7 by 21 and 14 by 20. So now tell me, earlier I did 1 by 17. Actually, if we do by negative method, it will be 17 into 3 is 51. So we could have done 3 by 51 also. Instead of 7 by 119, you could have done by that. I discussed like that. 7 by 29. Okay. 7 by 51. So here it is. 14 by 31. Here also got negative. 35 by 51. Here it is 35 by 51. Now, you see, using one method, n by a by 7. Earlier is showed by multiplying by 7, but it can, instead of you can multiply by, it is a choice. Either you do positive method by multiplying by 7, both numerator and denominator, or multiply by 3 by 3 in both numerator and denominator, and then it will be done by negative method. Say 8 by 17 can be expressed as either 56 by 119 or 24 by 51. Positive method starts dividing 56 by 12, or negative method starts dividing 24 by 5. Here you are directly getting 0.4705888235. Here you are getting 0.470. Instead of 58, we get 6 and vinculum 2. 6 vinculum 2 is actually 58. Yes. Then 8, if you're matching, see, 2, 3, 5, 2, 9. Instead of 2, 9, you're getting 3 and 1 vinculum. This is the only difference you get in vinculum. The rest of the things, they are matching completely. This is also your task. You just see, you repeat this thing yourself on your paper. You write 56, you start dividing by 12, or 24 you divide by 5 with negative method. You get like this. Okay. So regarding decimal, these are the tasks given to you. Some of them, at least some of them it can do. Now periodicity. See, 41, suddenly you're getting, why you're getting only 5? Earlier you're getting for 19, you got 18 digits for something. For 41, something by 41, you are getting only 5 digits. Where? Why? You could have gotten 40 digits also, but why is only 5 digits? 41 is like prime also, because like this. Because this recurring part of the decimal point depends upon the factor of repeat 9. 9, 99, 999, etc. Denominator d is equal to 3, only 3. Periodicity is 1 because 3 is a factor of 9. 11 has periodicity 2 because 11 is a factor of 99. This 27 or d, denominator 37 has periodicity 3 because they are factors of 999. Okay. 41 has periodicity 5 because it is a factor of 99999. 5 numbers of 9. So that's what it is, a behavior is like that. So these are all having 6 periodicity. So here there is a table. Can you see the table? In fact, 41 into 271 into 9. If you multiply, just to calculate also you can do, you write 41 into 271 plus into 9 is 99999. So these are the factors. This 271 is also prime number. And of course, you multiply by 9, so that way it goes like that. Periodicity 2, 3, 4. 4 will be only one thing will have periodicity here because 101. 101 into 99 is 9999. So therefore, it has periodicity 4. These will be periodicity 5, 6, and so on. See, 18. 18 periodicity, 19. The 18 numbers of 19, 18 numbers of 9 will have a factor of, this 19 is a factor of that. So therefore, for 19, it has length was 18 days. Okay, now tomorrow, in the next class, we'll be having divisibility rules.
Guruji,
Question?
No, sir.
Whatever is taught, we practice it. Huh? If any question comes, you tell me. First, you completely master the positive method. Negative method, it is optional. You can do, but sometimes it actually, because see, there is no way actually, if the denominator ends in 1, there will not be any preferred method other than going to the negative method. You'll find it. But anyway, first you master the positive method. You say something by 7, 13. You see this, you can yourself do, you do 1 by 69, for example, something by 69. I'm sorry, not 69. You do something by, say, 23. You take my task, you do 23, say 5 by 23 or 8 by 23, you do.
Guruji, can we finish the class, stop recording and then continue? It is
Right.
overshot time.
Okay.
Is it okay, Guruji?
Yeah.
Okay. Aditi, can you please recite Shanti Mantra? Then we will recite anthem, national anthem.
Yes, sir. Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschit dukkha bhavet. Om Shanti Shanti Shanti.
We will stand up for national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष माहे, गाहे तव जय गाता, जनगण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे, जय 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 हे, जय हिंद. Dhanyawad. I'll close the recording and then we can continue.